So welcome back to the Alba CBM5. This is the receive section of the video. In between me finishing the transmit side of the video, I decided to take the front panel off the radio because the three controls on off volume, squelch and RF gain were frozen. I could just about move squelch, and I also noticed that there were noisy as well. So what I've been able to do is to spray Servicol switch cleaner into the gap. There is just a gap in each one which enabled me to get the spout into. In fact, is that loose? No. So I've done the Servicol, and then I sprayed or applied WD-40 to the spindles, and I let that soak in for about 90 minutes. And so I thought, well, while the lids are off and the front's off and knobs are off, I'll run those through the company dishwasher, which, as you know, I enjoy doing. So we're on receive, and that's pretty abysmal. It's 3 microvolts. So we'd expect the radio to do better than 1 microvolt. So if I turn that down, it's gone. So it's as deaf as a post. So let's see what we can do to improve that. Well, what I've done, as I said with the transmit side of the video, I've got all day today I can do this video, and so we've set up a camera on the instruments, and to that end hopefully we can switch the mixer to picture-in-picture, and hopefully there we go. So what we've got is one of the oscilloscopes, and I replaced the aging Micronta ones because one of them had gone wrong with these. There's one to the right as well. The cheap Chinese ST16Cs are about £100 each delivered. I wanted CRT oscilloscopes, despite this being 2020, because when I make these adjustments I want to be able to see instantaneous results, and one of the problems I have with digital instruments is there's a fraction of a second in waiting, and it's adjust wait. I don't want that. I want it to work. So I've bought these. Are for me. They're not to impress the neighbours, and that's why we're using dead cheap Chinese oscilloscopes. And then on top of that, we've got the Motorola cyanide meter on this bench, and the plan is that as the signal gets better, the reading goes down on that meter. As it gets worse, it's up. So it makes it very, very easy to adjust FM receivers. So back to my crib sheet, and from the circuit diagram I came to the conclusion that receive is T9, starts with T9, T10, T11, T12, T13, T14, T15, and I think the detector's T16. So that's what we are going to do right now. So I'll just put a little bit more volume on, and we will start with T9. Wow. And you can see on that cyanide meter how we can get that peak, even though you can't hear that peak. So it's alright trying to tune these things up by ear, but you do need the instruments certainly in a commercial environment. So I'm now turning down the signal generator. So we're now at, so we started off at 3 microvolts. We're now at 2.7 microvolts. Now I shouldn't be using a metal tool, but hey, it works for me. So I'm going to turn down the signal generator again. Now we're at 2.2 microvolts, and we'll move on to T11. Fraction of improvement, T12. Massive improvement, so much so I'm going to have to turn the signal generator down. these two are interactive, so I'm just going backwards and forwards on them. And again, I'm having to turn the signal generator down. We're now we're at 1.7 microvolts now. So you can start off thinking that the radio is actually faulty when it's either had screwdriver trouble or simply just needs to retune because of the age. Recording this in 2020, even this radio made in 1985 is what, 35 years old. So move on forwards to transformer 14, which is that one there. Transformer 15. That's quite an improvement. Turn down the signal generator. So at 1.5 microvolts now. Right, we'll go through it all again and see whether we can get another improvement. And yes, we can. It's all interactive. So we're now at 1.2 microvolts. Turn the signal generator down. I think this is about where we've got it. Going to turn it down a bit more, see if we can get that fraction. And I'm going to start again with 9 and 10. Signal generator down. Signal generator now at 0.9 of a microvolt. I just wonder if I've got a plastic one for this. Yeah. Except it doesn't grip very well. Change ranges now on the signal generator. Now at 0.85. 0.79. Really ought to get a plastic tool on that. Just pause the video and restart with a plastic tool. Turn the signal generator down again. No, I think we're there now. Oh, I don't know. And again, turn it down. This is going to be the most sensitive Alba CBM5 in Britain. But they can't spend this time at the factory. Down again. And again. Just check those later ones, 11 and 12. No, I think we've milked it for all it's worth. So that's 0.55 microvolts. Which by today's standards isn't fantastic. And what does that, what do we get for 20 dB cyanide? Let's see. For 20 dB cyanide, it's 3 microvolts. For 12 dB cyanide, it's 2 microvolts. But it is receiving, there is 0.6, 0.5, 0.4, just under 0.5 it's going down to, which if I remember rightly it says better than 0.5 in the instruction book for the Good Buddy, which is the same chassis. So that is the receiver set up. Now we need to set up the S meter. So I've put 100 microvolts on the signal generator, and let's see what the S meter says. It's over the end. It's gone beyond full scale deflection. Now I worked out that RV3 is the S meter adjustment. So RV3 looks like it's that one there, which looks like it's that one there. So we want that to be S9. It's a bit bright on the looking at the monitor. It's a bit bright to see, but I can assure you it's spot on the 9 at that. So we know that's calibrated as it should be. So we'll see what it's going to be like when I actually try the radio on the air test. Although we're going to have a little play on the aerial when I've done this. Also, where I've got aeroplanes going overhead, if you can hear that. We're 4 miles from Cranwell, RAF Cranwell, and 2.5 miles from RAF Barkston Heath, and 16 miles from RAF Waddington, and we often get military aircraft probably logging onto my signal generator. So what we're looking at on the oscilloscope is I'm looking for a maximum amplitude, and we're going to do the detector, which is transformer 16, which is the one just down there. So the detector maximum smoke, as my old boss would have said, so that's less. We actually gained a fraction there, wasn't far out at all. So 1 microvolt, 0.5, much under 0.5, and it's disappeared. RF gain actually works. Yep. So now it's time to set the squelch. So we'll turn the signal generator off. I'm going to reposition the camera so you can just see the signal generator controls. So there we are, showing the signal generator controls and the corner of the soldering iron. So I'm going to set the squelch on the radio to threshold. Actually, I never worked out which is the squelch on here. So what have we got a choice of? 4 and 5. I hadn't worked out what was what. 4 and 5. You can see 5 there. Can't even see a 4. Doesn't mean there is one just because I wrote it down. So this, I wouldn't expect it to be there though, to be honest. Ah, what about 6? That's RF. So the squelch preset is what? 6. That one there. So I've set the threshold. We'll put the signal generator back on. It's coming at 1 microvolt. Set the signal generator, set the squelch to full. It's coming at 10. We need it coarser than that. Now, if I remember rightly, this is where this chassis really lets itself down. See whether we can open that. We can. Let's see whether we can close it. So I've got the preset on full now, and it's opening with S9, which is 100 microvolts. So it's open. We've got that to 0. So it's 100 microvolts. And it shuts back off at 30 microvolts. Actually comes in about 0.6, goes off about 3.5, so it tracks all right. So I'll turn that back down to minimum, turn the signal generator off, and we'll redo that test. So we'll set the squelch to threshold. There we go. Switch the signal generator on, and as we advance it, here comes 1 microvolt. Here comes 3 microvolts. So it's a compromise. We would have liked it a little bit more sensitive than that. Perhaps it's something you have to play with the RF gain control. But we need it to be strong enough to do an S7 signal. Otherwise it'd be very wishy-washy. So there's full squelch, and it's squelching it out. So not perfect, but I know this chassis is let down in that direction. And I think that covers the receiver. So as soon as the dishwasher has finished washing the various case parts, we'll put this back together and we'll plug it into the aerial and see if it still does anything. So I've plugged the aerial into the now finished Alba CBM5. And we can see, I'm going to turn this studio light off because I'm not sure that you can see the meter. Now, although we can't hear anything, the needle's all over the place, which is what people say. We'll just flick round the channels. I have had a chat to somebody 4.5 miles away. back to 19. So there's not anybody within the range. It's not unexpected, but some of the really sensitive sets will pull people in from Nottingham, which is 35 miles away. When we do the on-the-air test with this, I'll be surprised if we get the full 6 miles with it having a less sensitive receiver, which nevertheless could hear down to 0.5 of a microvolt. We normally do these videos on the camcorder, but as soon as I put that second camera on, I thought we may as well run it through the video mixer, and I'll just put this studio light back on so you can see its pretty face. We'll turn the squelch up. So, unusual but basic set. Public address feature, the minus 10 decibel, so it's down to 0.4 of a watt for the UK licensing at that time. Channel 9 switch. That erratic E meter, which we can still see moving. You've got the receive and transmit. 19 Roger. Yeah. Volume, squelch and RF gain. So we're doing on the air test, and then we can persuade Mr. Chippy to come over, and that will be uploaded in due course. So I thought it was time we did this, and so the Alba CBM5 is finished. Thank you for watching.